Alright, this is an average function problem. It states that the function of t, f of t, is equal to t minus 5 all squared, and that we're interested on the interval 0 to 12. And I would just like to show where the formula comes from. So if we were to integrate this actual function, we would find the area under the curve, the area under f of t. But we're interested in the average value, so what we're going to do is we're going to find a linear approximation. So this flat line here is called f average, and what it is that along the same interval, so in other words along that interval a to b, we are looking to set the area of this red rectangle equal to the area of this blue area under the graph of the blue. So in other words, we are looking to set the red area equal to the blue area to find what the average value of this blue function is. So we're interested, what is the average value of this function in between a and b? If we averaged all those up. So we decided to set the area under the blue curve, or f of t, equal to the area under this linear approximation called f average. And so you'll notice that for this red rectangle, the height is actually f average. It's y equals f average. So for the red rectangle, y equals f average. And the width of the rectangle is equal to b minus a, right? Because b minus a will give you the area between b and a. So this is b minus a in width. So we want to set the area under f of t, which is the blue curve. We want to set the area under f of t, which is the blue curve. And remember, to find the area of a curve, we are going to integrate it to find the area under the curve. So the integral of ft dt is the area under the blue curve and to the x-axis, or the t-axis in this case. And then we're going to set it equal to the area of this red rectangular approximation, which has height f average times its width, which is b minus a. So we're going to go ahead and divide b minus a over here because we want to solve for f average. So with that, we find the formula that f average equals 1 over b minus a, the integral of ft dt from a to b. So we're integrating from a to b and the rectangles from a to b as well. So with that knowledge, now we can go ahead and plug in our function, which in this case f of t is t minus 5 quantity squared. So we have t minus 5 squared with respect to t from a to b, and a and b in this case is 0 and 12, the endpoints of the interval. And also in this part, b is 12 and a is 0. So 1 over 12 minus 0 equals our average value of the function. And so now it's a matter of integration. And so I'm going to go ahead and make a little bit of room here. So you don't actually have to use u substitution for this problem, and the reason why is because if we choose u to be t minus 5, then the derivative of u with respect to x is just 1, and anything multiplied by 1 doesn't change that thing. So, but I'm going to go ahead and do it anyways because it's always important to just check and make sure that your u substitution isn't affecting anything. So I'm going to go ahead and let my u equal my t minus 5. T minus 5. Then I'm going to take the derivative of u with respect to t, du dt, equals, well, what's the derivative of t minus 5? Derivative of t is 1, derivative of minus 5 is 0 because it's a constant. So we can multiply the dt over and prove that du is in fact equal to dt. So now we can do our substitution. So f average is still equal to 1 over 12. 12 minus 0 is just 12. Integral, our boundaries are going to change because of our u substitution. But now that t minus 5 equals u, t minus 5 is squared, and u is t minus 5, therefore we must have u squared. And dt equals du, so where there was a dt, we'll now put a du. Now we just need to figure out what our new boundaries are for this integral. And to do that, we'll use this equation for what u equals in terms of t. So we know that we're going from when t equals 0 to when t equals 12. So let's plug in t equals 0 to this formula. U equals 0 minus 5. Well, that gives us minus 5. So our lower boundary, we plugged in 0 for t, and we got negative 5 out for u. So now what we're going to go ahead and do is we're going to plug in our upper bound, 12, for t, and figure out what u is. So we have 12 minus 5. I believe that's 7. So our upper bound is u equals 7. All right. So now what we're going to do is we're going to integrate this new expression up here, which is now in terms of u. So the integral of u squared with respect to u, we use the reverse power rule, and it's u to the third divide 3. And then we're going to evaluate it from negative 5 to 7, and then multiply it by 1 over 12 in order to get f average. So how we're going to go ahead and do this is we're going to say that f average is equal to 1 over 12, and then we're going to evaluate the integral. So we're going to plug in the upper bound first. Wherever there's a u in this formula, there's going to be a 7 now. So what we have is 7 cubed divide 3, and that's evaluated our first term, our upper bound. Now we're going to subtract our evaluated lower bound. So that's subtracting wherever there's a u, there's going to be a minus 5. So now we have minus 5 cubed divide 3. And this is our solution. So now we just need to work through it. So we've got 7 cubed, which is 343, still over 3, and we're subtracting negative 5 cubed, which is negative 125, still over 3. And we're multiplying everything by 1 over 12 to find f average. Alright, so common denominators, so let's go ahead and distribute this minus sign into here. A minus times a minus is a positive, is a plus. So we're now adding these together. And they have the same common denominator, so 343 plus 125 is 468. Divided by 3 is 156. So this whole term is equal to 156. Well, now we have f average is equal to 1 over 12 times 156, which is 156 over 12. And it happens to divide out evenly to show that f average equals the value 13 for this specific function on this specific interval. So I hope this was helpful, and I'll see you next video.